Hello students, welcome back, and in this video we are going to deal with an important identity of Fourier transform, and that is Parseval's identity of Fourier transform. The identity states that if f of omega and g of omega are the Fourier transforms of f of t and g of t respectively, that is f of omega is the Fourier transform of f of t and g of omega is the Fourier transform of g of t, then we have two identities. One is integration minus infinity to plus infinity f of omega g bar of omega d omega. This is equal to minus infinity to plus infinity f of t g bar of t dt, where g bar of omega and g bar of t are the complex conjugates. Okay, complex conjugates in the sense we have, for example, we say that g bar of omega, I can write it as g of minus omega, right? So this is nothing but the complex conjugate of g of omega, and the similar thing we are going to write it for g bar of t, right? The second identity states minus infinity to plus infinity mod of f of omega square d omega is equal to integration minus infinity to plus infinity mod of f of t the whole square dt. So these are the two identities we are going to prove today. Let's prove the first one. So before proving the first one, we should know what is the value, or what is f of t, or what is g bar of t, or what is f of omega, what is g bar of omega, right? So we know that f of omega is 1 by root 2 pi minus infinity to plus infinity f of t e to the power minus I omega t dt, and f of t is 1 by root 2 pi minus infinity to plus infinity f of omega e to the power I omega t d omega. Now we will start with proving this first identity by taking the RHS first. So we are going to take the RHS first. So we have minus infinity to plus infinity f of t g bar of t dt. This is equal to, now I'll keep f of t as it is, that is minus infinity to plus infinity f of t, and g bar of t I will substitute here. Since it is a complex conjugate of g of t or f of t, I can write this as 1 by root 2 pi integration minus infinity to plus infinity f of, sorry, here it's going to be g bar of omega, and this will be e to the power minus I omega t d omega, and the whole thing into dt, since we have a dt there. Right? Since it's a complex conjugate, I have a minus omega. I told you g bar of omega is nothing but g of minus omega. Right? So now, what I'll do is, I'll interchange the integrals. So what I'm going to do is, I'm going to take the d omega on the other side and dt in the inside part. So I'm just going to interchange them. So I'm going to write this as minus infinity to plus infinity. G bar of omega, I take it outside in the first integral, okay, and in the second integral I put the f of t. So that is 1 by root 2 pi minus infinity to plus infinity f of t e to the power minus I omega t into dt and d omega. So this is how I am interchanging the integrals. Now what is this? This is nothing but f of omega. So this I can write it as minus infinity to plus infinity g bar of omega f of omega d omega, and this is our LHS, and thus root. To prove the second identity, I put g of t is equal to f of t. So when I put like this, I am going to get g of omega is also equal to f of omega, or g bar of t is also equal to f bar of t. So now, I am going to substitute this in the first integral, because we have already proved it, right? So we are going to write it as integration minus infinity to plus infinity f f of omega, f bar of omega, f of omega, f bar of omega, d omega. This is equal to minus infinity to plus infinity, f of t g. Instead of g bar of t, I have f bar of t dt. As I told you that g bar of omega or f bar of omega is nothing but f of minus omega. So f bar of t will also be equal to f of minus t. So I'm going to just substitute it there. So it's going to be minus infinity to plus infinity, f of omega into f of minus omega d omega. This is equal to integration minus infinity to plus infinity, f of t, f of minus t dt. So if I try to get the accurate value, I'll just put the mod there, and this will be minus infinity to plus infinity mod of f of omega square d omega. This is equal to minus infinity to plus infinity f of t mod square dt, and this is our identity. So the main thing is you have to put g of t is equals to f of t. That is the main point we have to keep in mind while proving the second identity. So this is the Parseval's identity of Fourier transform. Now if I want to write it in terms of cosine transform and sine transform, so these will be the identities. That is, for cosine transform we have 2 by pi 0 to infinity fc of omega gc of omega d omega. This is equal to 0 to infinity f of t g of t dt, and 2 by pi mod of fc of omega the whole square d omega is equal to 0 to infinity f of t square dt. And similarly for sine transform we have 2 by pi 0 to infinity fs of omega gs of omega d omega is equal to 0 to infinity f of t g of t dt. 2 by pi 0 to infinity fs of omega the whole square d omega is equal to 0 to infinity f of t the whole square dt. Remember, it's a mod, so we can't get a minus sign there. I hope Parseval's identity of Fourier transforms is clear to you all, and if you have any doubt, please comment on the comment box, and please watch, like and subscribe and share it to your friends so that they will be benefited. Thank you. Hope you have a good day.